Welcome to the Chapter 1 to 3/8 exam review. This is mostly reviewing Chapter 3 and Chapter 8, but it also has stuff from the very beginning, from Chapter 1 and 2 also. You probably hope that this was a tour of the Patagonian ice caves, but it's not. What I'd recommend you do is go to the problems that you want help with and skip over the ones that you know cold. I guess you might try them just to make sure you've got the answers right. But also a strategy would be to try to work the problem first yourself and then go on and see how I work it and then try to work it again. Okay, and also the answers will be on your review sheets that I'll pass out. Same information as this. If you have if you come to a problem that's difficult for you, well then you can go back over it several times. You can just rerun and go back it. So, good luck. Okay, so we're starting out with things that are reviewing Chapter 1 and 2. So this one's find the value of the expression, an order of operations problem. So you know order of operations is uses PEMDAS. Remember that first thing is parentheses, then the second thing is exponents, and then after that multiplication or division, whichever comes first, and after that addition or subtraction, whichever comes first, from left to right. Okay, so we see here we have a bunch of parentheses. Now we know how to distribute, so we could distribute, but that actually is more trouble. If you can add the stuff that's in the parentheses, do it. Okay, so the top would be 6 times 2 plus 1 would be 6 times 3. And then the next one is 1 plus 1 is 2, so negative. So we have a negative 7 times 2. And by the way, the fraction bar is a grouping symbol like parentheses. So we can do the top and then we can do the bottom. Okay, down at the bottom, the parentheses 4 minus 2 is 2. So we have 6 times 2, and then minus 2 to the third power. Okay, so the next thing we do is 2 to the third power. And we might as well multiply these other things out too, because they're not hurting anything. So you've got 6 times 3 is 18, negative 7 times 2, negative 14. On the bottom, we'll do the exponent first. 2 to the third power. 2 times 2 is 4, times 2 is 8. So it's negative 8. And so also the negative part of that is not cubed. It's just the 2. If that was in parentheses, it would be cubed also. And then 6 times 2 is 12. So now we can subtract or add 18 plus a negative 14, or subtract 18 minus 14. And that is 4. And 12 minus 8 is also 4. The answer is 1. Number 2, in the term 12x squared y, the number 12 is called the what of the term? Well, you need to know what each of these things is called. You've got, you've got 12 x squared, or x to the second power, y. Okay, the 12 is the coefficient. These the x and the y are considered variables. The 2 is an exponent. Each of these things, the 12, the x to the second power, and the y, are all factors. So it's good to know what all these things are. And the whole thing is considered a term. This is of the term. This is a term. Individual term. Okay. Number 3, simplify the expression. Again, this is an order of operations problem. And one thing different about it from the previous one is it has a variable in it, t. So we've got negative 5 minus 3 minus 4t. Okay, so now we do have to do distribution. That negative between the two, that we have to multiply that through. Either we think of it in terms of negating what's inside the parentheses or multiplying a -1, because -1 is understood to be there. Okay, so we'll do the distribution first. That's the multiplication that comes before addition or subtraction, which involves the 5. So we'll just recopy the 5. And -1 times 3 is a -3. -1 times a -4 is a positive 4t. Okay, -5 minus 3 is a -8. And we just keep the 4t. That's our answer. Number 4. Solve the equation. 2r minus 5 equals 2 plus 4r. Remember, an equation is like a balance. Whatever you do to one side, you have to do to the other. Okay? If you add something to one side, if you add a positive number to one side, you have to add it to the other. If you add a negative number to one side, you have to add it to the other. If you multiply something times one side, you got to do it to the other, and so on. Everything you do to one side of the equation, you have to do to the other, and do to the whole side. Okay, looking at this, first thing we do when we're solving an equation is we simplify both sides, combine like terms and so forth. Well, there's nothing to do in this one. So now we skip on to the next steps. We do the addition or subtraction to get our variables on one side and our numbers on the other. And you just pick a side. Usually, if you're not sure what side to go, put your variables on the left. In this situation, I'm going to put my variables on the right. So I'm going to put my variables on the right. I'm going to add a -2r to both sides. That eliminates the one on the left. On the right I have now 2r. Okay, so now I'm going to put all my constants or my numbers on the left side. To do that, I have to add a -2 to the right side. So if I do that, I have to add a -2 to the left side, and that gives me just 2r on the right side. On the left side, it gives me a -7. Okay, so I'm done with the adding and subtracting part of it. Now the only way to get it to be just r, because I want a positive r equals something, alright, I'm going to have to divide by 2. And I'll divide by 2 on the other side too. So those two cancel out. I get r equals a -7 over 2. Number 5. Another equation to solve. This one has fractions in it. So the easiest thing to do is to clear the fractions. You can add and subtract fractions if you want. But the more complicated something is, the more easily it's the easier it is to make a mistake, for me and for anybody. Okay, so you have to pick a number, the least common denominator of the denominators in these fractions. And here we have 10 and 5. So the least common denominator, the first one you come to in both their times tables, is 10. Okay, so I'll choose 10. I'm going to multiply both sides by 10. So that gives me 10 times 3/10 x plus 2/5, and that equals 10 times 1/5 x. Do the same thing to both sides. Notice on the left side I've got to multiply the 10 times 3/10 and times 2/5, or 3/10 x times and times 2/5. So I'm going to select an area over here to do my calculations. If you can do it in your head, go ahead, but you don't want to make a mistake. Okay, so 10 times 3/10 x would be 10 over 1 times 3/10 x. And you'd either get 30 over 10, which becomes 3, or you cancel out your 10s. 10 into 10 is 1, 10 into 10 is 1, 1 times 3 is 3, so the answer is 3x. Put that back in, 3x. Now I'm going to do the 10 times 2/5. 10 over 1 times 2/5. If you're not comfortable with this fraction stuff, you should really work on your fractions. This is something you should be already comfortable with. Okay, I can cross canceling. I either get 20 over 5, which is 4. 20 divided by 5 is 4. Or I cross cancel. Easier way, right? 5 into 5 is 1. 5 into 10 is 2. 2 times 2 is 4. Okay, so it's 3x plus 4. And that equals 10 times 1/5. Well, this I can do right here. I'll just put the 10 over 1, do my cross canceling, and it becomes 2x. Well, now the problem just got a lot simpler. And I'm going to put all my, try to arrange it so my variables are on the left and my constants or numbers are on the right. To do that, I'll add a negative 2x. Okay, you can't just move them over. You got to follow the rules here. So 3x plus a negative 2x is just 1x or x plus 4 equals 0. It's all right to have a 0 there. Now we're going to add a negative 4. And that gives us x equals a negative 4. That's our answer. Okay, another equation to solve. It's 6 times x plus 4 minus 6x plus 24 equals 0. Okay, so everything's on the left-hand side. So actually, first thing we start out with is combining like terms and so forth, simplifying the left side. We have two parentheses, and basically we have two distributions, because that negative in between, that subtraction, we've got to use that to negate what's inside the second parentheses. Okay, so let's get started. 6 times x plus 4 minus 6x plus 24. That equals 0. So we do one step at a time. This looks like a complicated problem. It's really not. But you can get scared easily. So just take it one little piece at a time. That's the secret here. 6x plus 24. That's our distribution. You know, you have to distribute over both numbers. Okay, and then this one we distribute the negative over both numbers. So it's a negative 6x minus 24, and that equals 0. Now, I don't know if you notice something here. We have 6x plus 24, and then we have a negative 6x minus 24. They're going to cancel each other out. The two 6 that we combine like terms, we're going to end up with 0 equals 0. And what that means is, no matter what you stick in for x, it's going to work. So it's all real numbers is the answer to this one. So you have to watch out for this. All real numbers. If you end up with an answer like this, don't assume that you've gotten the wrong answer. Okay, let's do the second equation. It's 2 times y plus 2 equals 3 times y minus 4. Okay, so we're going to do the distributions on both sides first. 2 times y plus 2 equals 3 times y minus 4. Okay, so we have 2y plus 4 equals 3y minus 12. Okay, so I'm going to add a negative 2y to both sides. See, now we're at the point where we add or subtract to get have our variables on one side and our numbers on the other, right? So you just do what you need to do that, following that rule about the balance, right? Add negative 2y, and that gives me 4 equals y, because 3y plus negative 2y is 1y, or just y, minus 12. I have to rewrite that up here. 4 equals y minus 12. Okay, so to have y, a positive y equaling something, we've got to add 12 to both sides. And this gives us y equals 16. Ta-da! Okay, translate the sentence to an equation, then solve. This is number 8. So it's an equation. So look for something. Look for where the equal sign goes. It says 5 times a number equals 4 less than 6 times a number. Okay, so equal sign goes right here where it says equals. Alright, so now we can have something on the left side and something on the right side. 5 times a number, 5x, or 5n, whatever you want to use for a variable, equals 4 less than 6 times the number. 4 less. If I had 4 cakes less than you, I'd have less cakes, you know. I would subtract the 4 from your number to find out how many I had. I know that sounds silly, but so anyway, we've got the 6 minus 4. Okay, 4 less than 6 times, oh, 6 times the number. 6 times the number, 6x. Okay, now the next thing it tells us to do is to solve it. Okay, so this is actually quite an easy one to solve. I'm going to, and if you're wondering why I sometimes have my variables on the right side, it's only because I like to work where I put I add a negative to both sides, so I like my variables to end up positive. But it doesn't work out, I mean, it doesn't matter because it's going to work out anyway. You'll get your variables positive anyhow, so it doesn't matter. It really doesn't matter. So I'm going to add a negative 5x, both sides. And so I end up with 0 equals, again, just x minus 4. Add 4 to both sides, and I get x equals 4. Couldn't be easier. Oh, one more thing I wanted to say is this has got 2 parts to it, so you have to make sure you get both parts. It says translate the sentence, which is what we did here. Translated the sentence, and then we solved it, right, to get the answer here. So we have 2 answers. Number 9, solve the equation for y. Okay, we do this a lot, and now that we're graphing, because we want to put things into slope-intercept form. But here it's just from chapter 2, where we had to solve for a particular variable, right? But we do it the same way. We've been doing it all along. So we're going to isolate the y. To do that, we've got to add a negative 7x to both sides. Negative 7x. I don't know why I put that plus in there. Let me get rid of it. Okay. Negative 7x to both sides. Okay, so 9y equals, and I like to get in the habit of putting my variable term first on the right side, plus 59. Okay, but I'm not done, because I want just y. I don't want 9y, and it has to be positive too. So the only way I can do this to get it just y without getting a y on the other side at the same time is divide by 9. Not 9y. If I divide by 9y, then I've got to divide the other side by y also. I'm just going to divide by 9. And this whole side gets divided by 9. So you can write it like that, or you can write it like this, because both things on this side get divided by 9. Alright, so on our left we get y, and on the right we get 7x over 9, which is the same as 7/9 x. See, and there we have our slope. And then this plus 59 over 9. And is it all right to have funny looking fractions in our answer? Yeah, sure. Actually, real life problems always have funny looking decimals and fractions in them. Number 10, solve the formula for the specified variable, which is just like the last problem, only it has different variables. So just because something looks different, has different variables, doesn't mean you can't do it. Just use the same methods we've been using all along. We've got to isolate the variable that is the one that we're solving for, right? So in this case it's C, and this is the conversion from centigrade into Fahrenheit. If you know what centigrade is, or Celsius, temperature is, you put it into this equation, you plug it in, and it'll give you the Fahrenheit, what we're used to thinking of here in our non-metric United States. Alright, so to start off, to isolate our variable, to get it alone, we're going to add a negative 32 to both sides. Okay, so that gives us f minus 32 equals 9/5 c. Now, we want to get rid of the 9/5. The easiest way to get rid of the 9/5 is to multiply it by its reciprocal, 5/9. 5/9, I'll show you over here, 5/9 times 9/5 will equal 45 over 45, which is 1, or you cross cancel, you see, and that gives us 1, right? So that's the way to go. Alright, so I'm going to have to do it to both sides. I can multiply both sides by 5/9. You can do it one at a time. You can multiply both sides by 5, cancel out the 5, and then go ahead and divide by 9. But this is the fast way, easy way. Okay, so 5/9 times 9/5 c. There we go. Okay. So I'm going to leave the left side just like that. That's fine. Cross cancel these. So I'm going to keep 5/9 times f minus 32. Because if I multiply through with that 5/9, it doesn't make it any simpler or problem. Then we've got two big fractions. This is a little neater. And if you're making a conversion from Fahrenheit into Celsius, it'd actually be easier doing it this way. You just take your temperature and subtract 32 and multiply it times 5/9. Okay, so now we're getting into the chapter 3 stuff. Number 11 is plot the ordered pairs. We have 6, -4, and -3, 0. Remember, in a set of ordered pairs, the first one is the x and the second one is the y, just like they come in the alphabet. The x comes before the y. Okay, and this is our y-axis, right? And this is, that's our x. I'm sorry, our x. And this is our y. Yipes. Okay, so the horizontal axis is the x. All right, so we'll take the first number is 6, and we'll go over 6. See if I can get this thing. Yeah. Okay. Start here. Go over 6, and then down 4, because the y is the 4. 1, 2, 3, 4. So that's right there. It's hard to make a little dot with this thing. Okay, so that's 1. All right, the next one is -3, 0. So counting from here, -3 is right here, and 0, it means it's right on the line, right there. And we're done. You don't have to make them quite as fat as I've made them, but it'll do. Number 12. Complete the table of values for the given equation. 3x plus y equals a -22. Alright, so it's given us the x's. It wants us to fill in the y's. We're going to have 3 of them, right? 1 for each. They'll be ordered pairs. So we take our equation. 3x plus y equals -22. Alright, the first one is -8, so we just plug that in. This is just a plug-in situation when we're finding the other variable. 3 times -8 is -24, plus y equals -22. Now you see why you have to get good at working these equations, because they're not going away. Alright, so we're going to add 24 to both sides. Gives us y, positive y, which is what we want, and then the answer. -22 plus 24 is 2. So that gives us our first one. It's 2. Okay, now I'm going to plug in 0. Plugging in 0 for x is easy, right? It's our intercept. It's our y-intercept. We plug in 0 for that. That makes this just go away. and we have y equals negative 22. That's hard to write in there. Okay, and then the last one is 1. So we'll rewrite our equation. Erase this back out. Rewrite our equation over here. 3x plus y equals the negative 22. Plug in 1. 3 times 1 plus y equals the negative 22. Add a negative 3 to both sides. And we get y equals negative 25. So negative 25. That's all there is to it. It's just you plug in the x's and you find out what the y's are. There's nothing mysterious about this. Number 13 says complete the table just like we did in the last one, only this one's vertical. But that doesn't matter, right? We're given a bunch of x's. We're going to find the y's. And then it says, then determine the x-intercept and the y-intercept for the graph of the equation. Okay, I'm going to change the size of this so it's easy to work on. Okay, so we can complete our table now. Alright, negative 6. Stick it in for x, right? It's in the x column. So we have x plus y, x plus y, that's some x. Right, x plus y equals a negative 3. Negative 6 plus y equals negative 3. Okay, add 6 to both sides. Y equals 3. Alright, now we're going to substitute negative 3 for x. Negative 3 plus y equals negative 3. Well, you can see if we add 3 to both sides, that one's going to disappear, right? And we get y equals 0. Y equals 0. That's our x-intercept. Y is 0, it's our x-intercept. Just to keep that in mind. Okay, now we'll substitute in 0. 0 plus y equals negative 3. And so we can see automatically our y is negative 3. That's our y-intercept, right? Where x is 0, it's our y-intercept. Now we have 3 entries for y in our table. So this is a point where you can see if there's a pattern. If there's a pattern, well, it has to be a pattern in the x's. Notice that in the x's, it goes from negative 6 to negative 3. So it goes up 3, and then it goes up 3 again, and then up 3 again, and up 3 again. So it's ordered on the x side. So it has to be ordered on the right side if it's going to be a line. So we'll notice on the right side it goes down 3. It goes from 3, subtract 3, you get 0, subtract 3, you get negative 3. So it would stand to reason that the next number would be negative 6, like adding another negative 3, and then the next one would be a negative 9. But I wouldn't just stop there, I would test it. Okay, so we'll stick in the 3 for our x. 3 plus y equals negative 3. Add negative 3, get that alone. Negative 3 to both sides. It becomes 0 plus y equals negative 6. See, so it's right. So stand to reason that the next one would be right too. If we substitute in 6, 6 plus y equals negative 3, and we add a negative 6, negative 6, you can see we get y equals negative 9. Okay, so now we have to find the intercepts, which we already talked about. Our x-intercept is where y is 0, so it's negative 3. And our y-intercept, so that was this one, and our y-intercept is where x is 0. That was also a negative 3. So what do you know? Number 14, graph the equation by finding and plotting the intercepts. Okay, so to find the x-intercept, we stick in a 0 for y. To find the y-intercept, we stick in a 0 for x. Finding the intercepts is an easy way to plot. It's easier than making a table. Though sometimes you have to make a table anyway. So let's see what happens here. We'll stick in a 0 for y first. So that gives us negative 5x plus 0 equals 0. So we get a negative 5x equals 0. So if we divide it by 5, or negative 5, notice that cancels out. X equals 0. So where y is 0, x is 0. Right? It's right here in the center. Y is 0. That's the x and the y-intercept. You notice? Both are 0 at that spot. So that's not enough to graph this line, because we need a slope. And actually we could figure out what the slope is obviously 5. If you add 5x to both sides, you're going to see you're going to have y equals, you'd end up with y equals 5x, basically 5x plus 0. We already plotted our thing. We go up 5, and over 1. You're right there. But this came before we learned about that. So let's do it the other way. Let's make our table. X, Y, because we need more points than just 1. So we've got 0, 0. So now the next one we could try, let's try 1. Where x is 1. So negative 5 times 1. Oh, that is very hard to see. Let's try again. Negative 5 times 1 plus y equals 0. So we've got a negative 5 plus y equals 0. So we'll add 5 to both sides. And we get y equals 5. Okay, so where it's 1, x is 1, y is 5. Which is right here. Alright, now let's just get one more point. Let's get where x is 2. So, I think I'll just write across our grid because it doesn't matter. 5 times x would be 5, in this case, times 2, plus y equals 0. So, negative 10 plus y equals 0. Add 10 to both sides, and we get y equals 10, which kind of stands to reason. Oops, I guess I should write it in to our little table. Start here, over 2, up 10, right there. That's our point. Now let's see if I can draw a line. This is always a tough part on this. Anyway, our graph would be something like that. Be easier with a ruler and a piece of paper. Number 15, complete the table. Then determine the x-intercept and the y-intercept for the graph of the equation. Y equals x plus 8 is our equation. And then the second question of it is, what's the rule for identifying the x and y intercepts, which of course we already know. Right? I'm going to make this bigger again. So let's complete the table. Y equals x plus 8. Pen wouldn't write. Y equals x plus 8. Alright, so we'll start out with negative 8. x is negative 8 when x is negative 8. So now since we have it in this form, it's actually a little bit easier. Put a negative 8 plus 8, 0. Okay, so for y is 0, this is our x-intercept, right? Okay. Okay, we'll plug in our next one. Y equals negative 4 plus 8. So y equals 4. Then y equals 0 plus 8. So y is 8 there. And then y equals 4 plus 8. So y equals 12. And then 8 plus 8. So in this case, y equals 16. So let's find our intercepts. We already talked about our x-intercept is where y is 0. If you think about the axis, where y is 0, which is right here, then if you have an x, well, this one's negative 8, it'd be back over here. See, so it has to, where y is 0, trying to get the arrow, where y is 0, you know, the point's got to be somewhere on this line. That is where it crosses the x-axis. So where y is 0, that's the x-intercept. And then, of course, where x is 0, that's the y-intercept. X is 0 here, so it have to be somewhere along the x. It would have to cross the x or intercept the x-axis. Okay, so basically that's the rule for identifying the x and y intercepts. Where y is 0, it's the x-intercept. Where x is 0, it's the y-intercept. If you want to find it from an equation, you just plug 0 in for y to get the x-intercept and plug 0 in for x to get the y-intercept. And you should think it through. If you get confused, just think it through. Draw yourself a coordinate plane and figure it out. Where does it have to be? You know, it can only be one place.